Hi everyone. Today we are going to discuss a very important and rapidly growing field in cybersecurity called AI-based cyber threat intelligence platform or AICTI. Every day, thousands of cyber attacks happen around the world. Companies lose billions of dollars because hackers steal data, lock systems using ransomware, and disrupt important services. The biggest problem is that there are too many cyber threats and too much data for humans to analyze alone. This is where artificial intelligence comes into the picture. AI helps organizations detect threats faster, predict attacks, and automate responses, reduce human workload. All these attacks are examples of cyber threats, and today we will learn how AI helps defend against them. Today, by the end of this session, you will understand what cyber threat intelligence is, why AI is important, how cybersecurity professionals investigate threats, and real world attacks and the lessons we learned from them. But before understanding AI, let's first understand the problem that cybersecurity teams face every day. Let's understand the CTI and the AI revolution. Imagine you are a security analyst in a big company. Every day you receive 20 million firewall logs, 10 million login records, and thousands of suspicious emails, hundreds of security alerts. How do you know which alert is dangerous? You can't manually read everything. That's why companies use AI. Organizations generate firewall logs, antivirus alerts, network traffic, authentication logs, email security alerts. For example, a large bank can generate billions of logs every day. Humans cannot analyze this amount of data, but AI can. It's like finding one malicious event among millions of logs is like finding one grain of sand on a beach. Why traditional security fails? Because too much data, too many alerts, too few analysts, and attackers move quickly. So, if we cannot manually analyze all this information, we need intelligence. This brings us to cyber threat intelligence. What is cyber threat intelligence? CTI. CTI is evidence based knowledge about existing or potential threats to an organization, including context, mechanisms, indicators, implications, and actionable advice used to make decisions around responding to threats. It answers three questions: who is attacking, how are they attacking, and what should we do? For example, suppose your company receives a phishing email. CTI helps answer who sent it, what malware does it contain, how these attackers are targeted other companies, and how can we stop it. There are four types of CTI. The first one is strategic CTI. Second one is tactical CTI, and the third one is operational CTI, and the fourth one is technical CTI. Let's talk about strategic CTI. Strategic CTI is a high level intelligence for executives and decision makers. It focuses on trends, geopolitical threats, and organizational risks. For example, ransomware attacks on hospitals increased by 40% this year. Here, the CEO can decide to invest more in cybersecurity. Next comes tactical CTI. It details on attackers, TTPs, that is techniques, and procedures used by security architects and blue teams. For example, hackers are using phishing email, fake websites, or stolen passwords. Next comes operational CTI. It is information about specific attacks or upcoming campaigns. It helps in incident responders and SOC analysts. For example, a ransomware group is currently targeting healthcare organizations. Next comes technical CTI. It is an indicator of compromise, IOCs, IP addresses, domains, file hashes, malware signatures. Now let's take an example. Think about a police intelligence where its strategic CTI would be crime trends, tactical CTI would be criminal methods, and operational CTI would be ongoing robbery, and technical CTI would be foot fingerprints. Now let's compare how CTI was done traditionally and how AI has completely changed it. In traditional CTI, everything was manual. Analysts had to read reports, search for indicators, correlate informations. It was slow, there were human errors, and analyst fatigue. For example, one analyst may read 20 reports per day, but AI can read millions. So there were limited data volumes and high risk of analytic fatigue, keyword based threat hunting only. But in AI powered CTI, it was AI automatically collects information, correlates data, finds patterns, and predicts attacks. It is NLP based threat hunting and OSINT. For example, a company A is attacked today. AI notices same malware, same IP, same domain being used elsewhere. AI can warn other companies before they are attacked. So, why exactly does this matter? Why are organizations investing billions in cybersecurity? Yes, let's see. Cyber threats are growing today. We have cloud computing, mobile apps, IoT devices, smartphones, and online banking. Everyone is connected devices become a possible target. Attackers are becoming smarter. They use AI generated phishing emails, deepfakes, automated malware, and social engineering. There is an example in 2024, several companies received phishing emails written entirely using AI. The emails looked so real that employees couldn't tell they were fake. Hence, AI can analyze huge amounts of data, detect hidden patterns, and predict attacks, respond faster. Cybersecurity is no longer just about installing antivirus software, it's about intelligence prediction and proactive defense. To understand how serious this problem is, let's look at some numbers that show the current cyber threat landscape. The first one is cybercrime cost $9.5 trillion. This means cybercrime is expected to cost the world approximately $9.5 trillion annually. To put this into perspective, if cybercrime were a country, it would have the third largest economy in the world after the United States and China. What contributes to this cost? The, the ransom payments, recovery costs, business downtime. Business downtime means companies losing money because they cannot operate, legal penalties, and reputation damage. Let's take an example about a WannaCry ransomware. Hackers created ransomware called WannaCry in 2017. It infected more than 30 lakh computers across 150 countries. Victims included hospitals, banks, universities, government agencies. Now let's talk about next, that is 2,200 and plus cyber attacks every day. This means approximately 90 attacks every hour, more than one attack every minute. What types of attacks can happen daily? Yes, it can be phishing attack, ransomware attack, data breaches. What are data breaches? It is stealing of information. Next is password attacks, website attacks, and many. Can you tell me how many of you have received messages like you have won a prize, click this link, your account will be blocked? Those are the examples of phishing attempts. The next one is 277 days to detect a breach. This is the one of the scariest statistics. because companies take approximately 277 days to detect and contain an attack. That's almost 9 months. Just imagine a thief enters your house. He stays there for 9 months. He watches everything you do. He steals your money and you don't even know. This is exactly what happens in cyber attacks. What attackers can do in these 9 months? Yes, they can steal passwords, install malware, create backdoors, steal customer data, and delete files. The next one is 60% of small businesses shut down. Yes, small businesses often cannot recover from cyber attacks because recovery is expensive. Customers lose trust and legal costs are high. Data is lost. Cybersecurity has become a business survival issue. Let's look at some real cyber incidents that changed the cybersecurity industry. The first one is SolarWinds attack in 2020. SolarWinds develops software used by thousands of companies to manage their networks. Their software is called Orion Platform, where hackers broke into SolarWinds. Instead of attacking customers directly, they attacked the company that provides software updates. They inserted malware into a software update. Customers downloaded the update thinking it's an official update, but the actual installed malware. This is called a supply chain attack. Let's take an example. You buy a sealed water bottle. You trust it because it came from the company, but someone poisoned it before it reached you. This is exactly what happened. It has impacted more than 18,000 organizations and including government agencies, technological companies, and security firms. So hence even trusted softwares can become dangerous. So AI would have detected anonymous and network behavior early on. Next, now let's look at an attack that affected an entire country's fuel supply. That is Colonial Pipeline attack in 2021. Colonial Pipeline transports fuel across the United States. Hackers from ransomware group called TAXII gained access to the company's systems. One employee account had a compromised password, no multi-factor authentication. What did hackers do? They installed ransomware. The company shut down its operations. It resulted in fuel shortages, panic buying, and long lines at petrol stations. Ransom paid approximately $4.4 million. Hence, we should learn from this that one weak password can disrupt an entire country fuel supply. Hence, now let's see an attack that exploited a software vulnerability. It is an incident number three, which we will be looking. MoveIt breach that happened in 2023. What is MoveIt? MoveIt transfer is software used by companies to transfer files securely. Hackers discovered a vulnerability before anyone else. This is called a zero-day vulnerability. What is zero-day vulnerability? A security flaw that the software company doesn't know about. They have 0 days to fix it. Attack group Klopp exploited this vulnerability. It impacted more than 2,700 organizations. Millions of individuals had their data stolen. Hence, AICTC platforms correlating dark web's chatter identified this threat after weeks before. Hence, these attacks teach us trust can be exploited, weak passwords are dangerous, vulnerabilities appear unexpectedly, and threat intelligence is essential. So, after seeing these attacks, the next question becomes, can humans alone defend against threats of this scale? The answer is no. And this is where artificial intelligence becomes the answer. Why is why AI is the answer for modern CTI? First is data volume. Companies generate billions of logs and millions of alerts. Humans cannot process this information, but AI can analyze millions of events in seconds. The next is pattern recognition. Humans may miss patterns, but AI can discover repeated IP addresses, similar malware, and attack campaigns. For example, company A is attacked today, company B is attacked tomorrow. AI notices same malware, same domain, same attacker. It warns company B before damage occurs. The third one is global threat feeds. AI gathers information from news articles, threat feeds, dark web, and security reports. Fourth one is predictive intelligence. AI predicts future attacks. For example, weather forecasting. Meteorologics predicts storms. AI predicts cyber attacks. Fifth one is automation and SOAR. AI integrates with SOAR platforms to auto respond to threats, isolating hosts, blocking IPs, creating tickets automatically. What is SOAR? SOAR is security orchestration, automation, and response. The sixth one is threat actor profiling. Deep learning identifies threat actor fingerprints, writing style, malware families, C2 infrastructure patterns. For example, traditional security, one security guard, AI powered CTI, an entire intelligence agency. Now that we understand why AI is important, let's understand the entire cyber threat intelligence process. This slide introduces three important concepts, that is CTI lifecycle architecture and intelligence pipeline. Cyber threat intelligence is not one time activity, it is collect, analyze, share, and improve activity. Let's take an example, a hospital continuously monitoring a patient's health. Let's now study the CTI life cycle in detail. This is the one of the most important slide that shows the life cycle of CTI. The first stage is direction stage, in which you need to define your goals, scope, and what questions the CTI program needs to answer. The question is, what do we want to protect? For example, customer data, bank systems, or research data. Next is the stage 2 collection stage. In this, information is gathered from logs, thread feeds, news, and data. The third stage is processing stage, where data is cleaned, duplicates are removed, and data is converted into usable information, that is in standardized format. The fourth stage is analysis stage, where AML models find various patterns, identify attackers, and predict threats. The fifth stage is dissemination, where share finished intelligence via dashboards, reports, APIs. The sixth stage is feedback, learn from mistakes, improve the process. Let's take an example of cooking, where direction is to decide the menu, that what should be, which dish or what should be made for eating. Next is collection, that is buying ingredients. The processing stage, we wash and cut vegetables. In analysis stage, we cook. And in dissemination stage, we serve. And in feedback, we ask everyone whether they like the food or not. Now let's go to the next slide. That is AML and techniques used in CTI platforms. So far, we have understood that what cyber threats intelligence is and why AI is needed. But what exactly does AI do? The answer is that AI uses several technologies like NLP, that is natural language processing, ML, that is machine learning, and GNN, that is graph neural networks, and deep learning, that is DL. Each of these has a different role. Let's talk about natural language processing. What is NLP? NLP is a branch of AI that enables computers to understand human language. It allows machines to read text, understand meaning, and extract useful information. Why is NLP important? Everyday cybersecurity information is published in news articles, blogs, research papers, dark web forums, and many more. No human can read all of it, but NLP can. For example, a hacker writes on a dark web forum, "We have found a new vulnerability in XYZ." NLP can automatically read the message, identify the software name, and determine the vulnerability. Alert security teams. Another example is suppose thousands of reports mention phishing emails pretending to be from banks. NLP can detect this trend automatically. Now, let's talk about machine learning. What is machine learning? Machine learning is a type of AI where computers learn patterns from data and make decisions without explicit proof. How does Gmail detect spam? It learns from words, links, and sender behavior and predicts whether an email is spam or not. In cybersecurity, ML helps in malware detection, anomaly detection, threat scoring, and fraud detection. Let's take a real life example, credit card fraud. Suppose you always spend money in Mumbai, suddenly a transaction appears in Brazil. Machine learning says this is unusual. The transaction gets blocked. In CTI platforms, ML can identify suspicious domains, malicious IPs, and new malware packages. Next is graph neural networks. This sounds difficult, but it's actually simple. In this, uh, what is a graph? It consists of nodes and connections. It is used for mapping relationships between IPs, domains, and actors. Attack graph analysis for lateral move. Entity resolution across disparate data sources. Knowledge graph based threat correlation. For example, an IP address may seem harmless, but GNN discovers this IP is connected to malicious domain, known ransomware, threat actor. Now the IP becomes suspicious. Next is deep learning and threat prediction. Deep learning is an advanced form of machine learning. It uses artificial neural networks inspired by human brains. Why use deep learning? Because cyber attacks are becoming extremely complex, and deep learning can detect unknown malware, predict attacks, and recognize patterns humans cannot. LSTM networks for time series attack prediction are used. CNNs are used for analyzing malware binary images. Transformer models for threat report generation and reinforcement learning for adaptive responses is used. Let's take an example. Deepfake detection. Hackers now use AI generated voice. Deep learning can detect synthetic voices and manipulated videos. So let's take a quick look. NLP is used for understanding text. ML is used for finding patterns. GNN for discovering relationships. And DL is used to predict complex threats. Yes. So our next slide is AICTI platform architecture. Now, this is very important as it explains how an entire CTI system works. Let's start with how the data flows through an intelligent threat intelligence platform. The first step is data sources. That is, data comes from many places. Open source intelligence, that is OSINT, open source intelligence. That is public information, news, blogs, GitHub, and social media. Second is dark web. These are hidden forums where cyber criminals sell data, share malware, and plan attacks. Third is threat feeds, database containing malicious IPs, domains, and hashes. SIM systems, security logs collected from servers, firewalls, and applications. Next one is honeypots. From data can be collected data that is fake systems designed to attract hackers. Now you must be having a question that why would we intentionally allow hackers into a system? Because we want to study them. Okay. The second step is ingestion and normalization. In this, data arrives in different formats, so system cleans it, removes duplicates, and standardizes the information. The next step is AI/ML engine. This is the brain of the platform. It performs classification, detection, prediction, and correlation with the help of various AI/ML techniques. Next step is threat intelligence layer. It stores intelligence such as threat actors, malware, indicators, and campaigns. The fifth step is action and integration. In this, the platform can generate alerts, block IPs, create tickets, and inform analysts. Let's take a real life example. Think of a factory where raw material enters and finished product comes out. AI converts raw data into actionable intelligence. Now let's understand some important cybersecurity terms that every analyst must know. So the key concepts you must know are IOC, that is indicators of compromise. IOCs are pieces of evidence that indicate an attack, artifacts left by an attacker on a compromised system. So examples of IOCs are IP addresses, domains, URLs, file hashes like MD5 and SHA-256, registry keys, email addresses, and SSL certificate. AICTI platform maintain live IOC databases updated in real time from global sources. For example, if an attacker uses IP to control malware, that IP becomes an IOC. Next is TTPs, that is tactics, techniques, and procedures. It describes how an attacker operates, documented in the MITRE attack framework. Tactics means goals, techniques means how, procedures means exit steps. AI models learn TTPs to predict next attack steps. For example, the attacker's goal is to steal the password. How they achieve this goal? It can be done using phishing email. Now let's talk about STIX. It is a structured threat information expression where a standard language used to represent threat intelligence. Different organizations use different tools. STIX provides a common language. Let's say, take an example. English language allows people from different countries to communicate. Next is TAXII sharing standards. This is trusted automated exchange of intelligence information. Protocol used to share CTI automatically. For example, STIX is the letter and TAXII is the post. The next one is MITRE ATT&CK framework. One of the most important cybersecurity frameworks, a huge knowledge base of attacker techniques, a globally accessible knowledge base of adversary tactics and techniques used by AICTI platforms to map observed behaviors to known attack patterns. For example, MITRE shows how attackers enter, how they move, how they steal data. These concepts form the foundation of modern intelligence. Now let's look at the platforms used by real cybersecurity professionals. So AICTI tools are there are some free tools, there are some enterprise tools, there are some commercial tools. So let's take a look. First one is MISP. It is a free tool used for threat sharing. It is a threat sharing platform where its features are IOC database management, STIX and TAXII integration, and community threat feeds. The next one is OpenCTI platform where it is a threat intelligence platform. It is a free platform and its features are knowledge graph visualization, MITRE and ATT and CK mapping, multi-score correlation. The third one is Recorded Future. It is an enterprise platform used for AI powered threat intelligence. The first one feature is dark web monitoring, predictive intelligence, and risk scoring for entities. The fourth one is Threat Connect. It is an enterprise platform. It shows intelligence driven security. The features are orchestration and automation, diamond model analysis, and CAL threat library. The fifth one is Anomaly Threat Stream. It is a commercial platform used for threat intelligence of ops. Um, the features are 1000 plus thread feed integration, sandbox integration, and thread bulletin creation. The sixth one is VirusTotal or Yara. It is a freemium that it is free and premium. It has files and URL analysis used for file and URL analysis. Features are multi-AV file scanning, AI enhanced ML detection, API integration support. The next, let's dive deeper into MISP and OpenCTI. These are the two most important open source platforms. Uh, MISP stands for Malware Information Sharing Platform, where it stores and shares IOCs across organizations, Galaxy clusters for threat actor attribution, correlation engine identifies linked events, MISP REST API for automated integrations. It is used by 6,000 plus organizations worldwide. It integrates with the Hive, Cortex, and Splunk. It is built in STIX and TAXII support. OpenCTI is Open Cyber Threat Intelligence Platform, knowledge graph for threat relationships. Uses MITRE and ATT and seeking native integration. It is incident campaign and actor management, Docker-based easy deployment, backed by ANSSI, that is French National Agency, connectors for MISP, Shodan, and Abuse IPDP, GraphQL API for custom integrations. The next is practical demonstration, that is hands-on walkthrough of real threat intelligence tools. So first let's talk about the tools. So I'll be talking about these 5 tools and then I will be giving you a demo on VirusTotal tool. Okay, so VirusTotal it is used to detect uh, any malicious any malware in file or anything you have downloaded or exported or imported from somewhere. So submit a suspicious file and it will analyze the AI enhanced scan results. It observes multi-vendor detection, behavior analysis, and relationship graph. Next is abuse IPDP. It examines the threat category, abuse confidence score, and reporting history from global security teams. Shodan it demonstrates how attackers use ASCENT and how defenders use it for asset discovery. MITRE and ATT&CK Navigator. It is the walkthrough. The ATT and CK matrix map a real world attack chain. Example APT29 slash cozy beer to specific techniques and show heat map visualizations. The fifth one is OpenCTI or MISP, that is, it shows the knowledge graph, IOC correlation, and STIX data structure using pre-prepared screenshots from a live deployment. So now let's go to Google and search for the World Virus Total website, and let's upload a file and let's have a demo. So we will be going to this first one. This is the official website. Yeah, so let's talk. VirusTotal is an online service that scans files, URLs, domains, IP addresses, and file hashes. It uses 70 plus antivirus engines. Suppose let's take an example. Employee receives an invoice and it opens it. The system starts behaving strangely. The analyst extracts the file and uploads it to VirusTotal. The first step will be that every file has a unique fingerprint called hash. The file will be hashed. It can be MD5 algorithm, SHA1 algorithm, or SHA256 algorithm. So let's first upload the file. We will see if the file gets hashed or not. Yeah. Let's go to desktop files. Um, yeah, so files can be of any form. It can be TXT file, it can be PDF form, or it can be Word, anything. So let's confirm the upload. This is the hash generated, and it is analyzing that is there any malware in this file or not. Uh, so out of 70, 60 of the detection systems have detected that there is no malicious thing in the file. Okay, so like 0 upon 60 is our detection ratio. This is known as detection ratio. This means that no virus is detected or no malware is there. So now let's see. So, 7 systems have not detected. So yes, let's go to the details option. Here you can see the basic properties, name of the file, safe pickle, classification, suspicious, justification, all. You can see file size, type of the file, text, txt. It's a hashed value MD5, SHA1, SHA256, and all. Yes, there is no comment on our file. Let's go back to detection. VirusTotal runs the file inside a sandbox for its behavioral analysis. Now, what is sandbox? Sandbox is a controlled virtual environment. For example, putting a dangerous animal inside a cage and observing it. What does sandbox show? It files created, registry modifications, network communications, and processes started. Step 4 is network indicators. Malware often communicate with domains, IP addresses, and command and control servers. Command and control servers are also called as C2 servers. Make a point of it. Command and control servers are called as C2 servers. Example, a hacker infects 10,000 computers. All infected systems connect to one C2 server. The hacker can steal data, encrypt files, and install more. Next is relations graph. Yeah, so in this next is one of the most powerful features, that is relation graph. This helps analysts understand the entire attack. Then comes YARA rules. YARA is often called the antivirus for malware researchers. Rules used to identify malware based on strings, patterns, and behavior. For example, if a file contains specific text, certain functions, known malware behavior, it can be classified automatically. VirusTotal is usually the first tool analysts use during malware investigation. So let's go to the next slide. This is what we just did. A hash value was generated of our file. Detection rate was 0. Behavioral analysis. We know sandbox is virtual environment. Then network indicators. C2 domains. What is C2? C2 is command and control servers. And we talked about relation graph and Yara rules. Yes, let's go further. Let's have a quick brief of the tools we have used. VirusTotal. It is used for file, URL, or IP reputation analysis and best for first step for an suspicious indicator. Next is Shodan, used for internet-wide device search engine. It is best for map exposed assets and find vulnerable services. The third one is MISP, that is IOC sharing and threat intel platform, best for community threat intelligence exchange. The third one is Census. Sorry, fourth one. It is used for internet scanning and asset intelligence, best for alternative to Shodan with more context. The fifth one is abuse IPDP. It is for IP reputation and abuse reporting, best for check IP reputation before trusting traffic. The sixth is MITRE, ATT&CK, adversary TTP knowledge base, best for map attack behavior to known techniques. Seventh is OpenCTI, used for threat intelligence knowledge graph, best for building internal CTI capability. URL house, malware URL database, and best for check URLs shared in phishing mails. Now let's talk about key takeaways that we studied today, that we have learned in this whole session. The first is CTI transforms raw threat data into actionable intelligence. AI makes this scalable and proactive, not just reactive. The threat landscape is evolving faster than humans can track. AI is not a luxury anymore. It's a survival tool for organizations. Yes. The third point is the CTI lifecycle, which we have discussed. It is starting from direction stage where we need to define goals, then collection of data, then processing, that is cleaning stage, cleaning of data, and then analysis, then dissemination, and then feedback. It is a continuous loop. AI enhances every stage. Fourth, we have studied about IOCs, TTPs, and the MITRE, ATT&CK framework, that are the vocabulary of the threat intelligence. Master them before applying tools. Fifth, open source tools like MISP, OpenCTI, VirusTotal, and Shodan are accessible today and used in real SOCs worldwide. Six, your career opportunity. AICTI is one of the fastest growing specializations in cybersecurity. The skills gap is massive. Yes. So now I would like to conclude. Cybersecurity is no longer just about stopping attacks after they happen, but it's about understanding attackers, predicting threats, and responding intelligently. Artificial intelligence is transforming cyber threat intelligence by making security systems faster, smarter, and more proactive. The tools we discuss today are the same tools used by the professional security analysts around the world. So, thank you everyone. If you have any queries, you can reach out at biotechrebion@gmail.com. Thank you for your time.